This video will cover reshaping data with pivot wider in dplyr. By the end of this video, you should understand what types of reshapes you can perform with pivot wider, the questions you should ask yourself before using pivot wider, and some of the options that you might use for performing reshapes with pivot wider. The R code used in this video is available on the Learning Management System. It uses the data file College Park Weather 2017_long.rds. You should download those now if you'd like to follow along. In previous videos, we did an overview of reshaping data. Remember, the data you have might not always be in the format that you want. Different applications might need different arrangements of data, and the format of data might depend on the way that it was collected. Sometimes your data are collected in such a way that they're not in a tidy format when they're provided to you. You can address these problems by reshaping your data. And remember, when you reshape data, you're going to take a rectangular table of data and output a different rectangular table of data, changing the numbers of rows and columns. In this video, we'll look at using pivot wider to look back at an example that we have before. Here are some non-tidy weather data where the temperature and relative humidity information are packed together in a single column named level. We'd like to spread that information out into a temp C and an RH column in an output table. We're going to accomplish this using pivot wider. However, before you pivot data into a wider format, you should always ask yourself the following questions. First, which variable or variables uniquely identify observations that you'd like in your output table? Second, which variable or variables should be used to construct new variable names in your output table? And third, which variable or variables should be used as values or the data in your output table? Let's think about these questions in detail with this example. So first, which variable or variables will we like to uniquely identify observations in the output table? You'll notice in the input table, we have multiple rows for each day and month of the year. In our output table, however, there's only one row, one observation for each combination of month and day. This is what we mean by the variables that we'd like to uniquely identify observations in our output data. In our desired output table, any particular combination of values for the month and day variable should only occur once. So this month and day variable are the variables that we use to uniquely identify each row in the output table. That's the answer to our first question. The second question is which variable or variables should be used to construct new variable names in the output table. Looking at that output table, we'd like to create variables temp C and RH, which have the temperature and relative humidity information. Those variable names come from the measurement column in the original table. So the answer to question 2 is that we would like to use this measurement variable to construct new variable names in our output table. The third question asks which variable or variables should be used as values or the data in our output table. Looking at our output table, the values for the temp C column and the RH column each come from the level column in our original table. So the answer to our third question is that we would like to use the level variable to produce the values that will be contained in our output table. So how do we accomplish this with pivot wider? Pivot wider, like many dplyr verbs, takes data as its first argument. You'll usually just pipe the data to pivot wider, replacing that first argument. It then takes 3 required arguments. The first is the answer to your first question. It's the variable or variables that uniquely identify observations. You give those to the ID cols argument. Next, you'll provide a list of the variable or variables that you'd like to use to construct column names as the names from argument. Finally, you'll provide the variable or variables containing values you would like in your output table to the values from argument. Like the majority of verbs in dplyr, you can use tidy select expressions, things like starts with, ends with, or contains, or vectors of variable names for any of these arguments. Remember that between these 3 options, you should list all of the columns in your original data. In other words, every column in your original data table will either be an ID column, a names from column, or a values from column. Let's look at using pivot wider in this example. The first question you should ask yourself, again, is which variable or variables uniquely identify observations that you'd like in your output table. We answered that as the month and day columns. Since there's more than one, you must put them in the vector function, and that's what I have here. I specify ID columns equal to C, the vector function, with the month and day columns as arguments. The second question was which variable or variables should be used to construct new variable names in the output table. Remember, we determined this was the measurement column, so for the names from argument, you should specify measurement. Finally, the third question asked which variable or variables should be used as values, or the data in the output table. We determined that was the level column, and so the values from argument should be set equal to level. Let's perform this reshape in R. First, I'll load my setup code. Importantly, I'll load a data file, College Park Weather 2017_long.rds, which contains something very similar to the examples that I've used in this video, except the file has many more observations. I'll run that. Let's take a look at the content. As you can see, I have the exact same variables as the example in the slides: month, day, measurement, and level. But here there are 712 observations as opposed to just the few that I had in the example. Let's go back and look at my code. We'll spread the data using the exact commands that we figured out in the slides. I'm going to take that weather.long tibble. I'll pipe it to pivot wider. The ID columns are going to be month and day. I'm going to get new variable names from the measurement column, and I'm going to obtain values from the level column. I'll save all of this to a new tibble, weather.wide, and then we'll take a look at it. I'm going to run that code. Looking at the output, you can see I've reshaped the data into a new format. There are now only 356 observations. There are values for each month and day, but no combination of those variables is repeated. And we have relative humidity and temperature columns. These are the basic steps that you'll need to follow whenever you'd like to use Pivot Wider. What I've shown you so far covers the basics of using Pivot Wider, but very advanced pivots are possible. So let's think about some details that you might run into in more advanced pivots. First is missing values. When using Pivot Wider, it's very possible that there's some combination of your ID columns and your names from variables that don't exist in your data. In some examples that we'll work on in a minute, we're going to make a column for every day of a month. Some months don't have 31 days. In cases where there's no corresponding value in your source data, R is going to make those values NA in the output table. If that's not the behavior you'd like, you can specify a custom value with the values_fill argument. Just provide the value that you'd like R to use instead of NA. You might also not be happy with the default column names. Remember, R is just going to look in the names from column and construct column names from the values in that column. You can use the names_prefix option to put some text at the start of every variable name before R starts using the value from the names from column. This names prefix option is very useful if your names from column contains numbers, for example, years, because it can be very tricky in R to deal with variable names that are just numbers. Adding that little bit of text beforehand can make it easier to deal with those variable names. We're going to use these additional options to perform a more advanced reshape. We're going to take the data that was the output of our last Pivot Wider operation. So remember, there is a month column, a day column, a relative humidity column, and a temperature in degrees Celsius column. What I'd like to do is pivot that data into an even wider format. I'd like to take the temperature variable and make one column for each day of the month. So I would have a month column and then a temp.1 column representing the temperature on the first day of the month, a temp.2 column representing a temperature on the second day of the month, and so on. Before we perform this pivot, we have to ask ourselves the three important questions. First, which column or combination of columns contain values that will uniquely identify rows in our output table? Looking at our output table here, this is just going to be the month column. The second question is which variable or variables would we like to use to construct the names of our new columns? We're creating a column for every day, and what you see is at the end of every column, we're going to have the day number. So we're going to use that day column to construct our column names. Lastly, which column or columns contain the information that will form the data in our output table? That's the temp C column in this case. Now that we have that information, we can take this to R and perform the reshape. Zooming in on the code window, I have the R code here necessary to perform that reshape. I'm going to take that weather.wide tibble, and the first thing that I'm going to do is pipe it to the select verb. We're disregarding the information in the RH column here. Remember that between ID calls, names from, and values from, we should list every column in our tibble. Since we don't need that RH information, I'm going to use the select verb to keep only the columns that I'd like to use for this reshape. I'm then going to pipe to the filter verb. I'm just going to filter to days less than or equal to 5 because I'd like my output data to be more manageable so you can see it on the screen. If I didn't do this, the resulting data would have 31 columns and would be very difficult to show. Then we're going to move on to the pivot verb. I'll provide the 3 required arguments. First, ID cols specifies the variable or variables that will form unique combinations identifying each row in my output data. That's just the month variable in this case. I'd like to construct names from the day variable, and then the values for those variables should come from the temp C column. Now the day variable is numeric. Numeric variable names are difficult to deal with, so I'm going to use the names prefix option to tell R that I would like the text temp dot to start every variable name that it constructs. It will then put the day number after that. Finally, there's an additional option, names sort, that will sort all of the variable names that it creates in alphabetical order. That makes it a little bit easier to look at them. I'll finally save that in the weather.monthly tibble, and we'll take a look at the output. So let's run that code. And you can see the output. I now have a tibble with 12 rows, 1 for each month, and 6 columns. The first is that month column, and then I have temp.1, temp.2, and so on, with temperatures for each day of the month. So far, all of the pivots that we've considered only take values from a single column. You may wish to take values from multiple columns. If that's the case, you can use a vector of column names as the values from argument. So R doesn't get things confused. The columns that it creates will begin with the name of each values from column when there's more than one of them, and end with the names from value. Sometimes you don't want that values from column name smashed directly against the names from value. You can put some text in between with the names _ sep option. So to look at these options in practice, I'm going to consider another reshaping example. I'm going to take that data that we created in the first pivot operation with month, day, relative humidity, and temperature columns, and I'm going to pivot it to a new table where there's a month column, and there are temperature and relative humidity columns for each day. This is much like the last example, except we'll have both temperature and relative humidity in our output data. Again, in each case, variable names will be something like temp C or RH, followed by a period, and then a number for the day of the month. We can ask ourselves the important questions. First, which variable or variables uniquely identify observations in our output data? Here again, that's just the month column. Second, which column or columns contain information that we'd like to use to construct the variable names in our output data? As with the last example, that is the day variable. And then third, which column or columns contain information, the data that we would like in our output table? Now we have 2 columns, both the relative humidity and the temp C column. Having answered those questions, we can then take this to R and perform this pivot. Zooming in on my code window, I have the R code here necessary to perform that pivot. I'm going to take my weather.wide tibble. I'm going to filter it down so I just have days of the month less than or equal to 3. Again, this is because I would like to make my output manageable so it will show up in the output window. If I didn't perform this filter, the resulting table would have 63 columns and would be really difficult to look at. I then pipe that to the pivot wider verb. My ID columns are again just the month column. I get my column names from the day column. I'm going to pull values from both the temp C and the RH column. When you have more than one values from column, R is going to construct new column names as first the values from variable name, followed by the particular value in the names from. Since we don't want that text smashed together, I use the names sep argument to say that I would like a period between the values from column name and the names from value. I'll save that to a table called weather.monthly, and then we'll take a look at it. So I'll run that code. Looking at the output, you can see I have a tibble now with 12 rows. There's a month column, values from 1 to 12. I have a temp C.1, .2, and .3 column with temperatures on the first 3 days of the month, and an RH.1, 2, and 3 column with the relative humidity on each day of the month. There are many additional options to pivot wider. If you have complicated pivots to perform, it's worthwhile reading through the help file, but the strategies that I've given you in this video will allow you to perform the vast majority of pivots where you're making your data wider and shorter.